Thank you for being here today at Healthcare NLP Summit. My name is Mugda. I'm a data science leader with 12 years of experience driving strategic planning and innovation through data-driven insights. My role at Medtronic is managing annotation and digitization for AI Center of Excellence, focusing on AI integration, digital transformation, and business intelligence. I'm leading digitization efforts to enhance data strategies and operational efficiency. With strong background in predictive analytics and market research, I have contributed to groundbreaking advancements such as predicting heart attacks in pacemaker patients and fall detection in sleep apnea cases. I'm passionate about operational excellence and fostering international partnerships, making myself a valuable leader in advancing organizational health. And I'm excited to share insights into how AI powered solutions are revolutionizing mental health care, and particularly for neurodivergent individuals. Today, I'll be talking about advancing healthcare with AI driven wearable technology by enhancing patient outcomes and neurodiversity support. I would consider it as a AI powered healthcare, which will like help predict, personalize, and prevent some just. Okay. Mental health is not one size fits all, especially for neurodivergent communities who process the world differently. While traditional mental health treatments work for some, they often fail to address the unique cognitive, emotional, and sensory needs for individuals with autism, ADHD, and sensory processing disorder. AI has the potential to change that by providing personalized data driven interventions that enhance mental health management. Today, we will explore how AI driven solutions analyze data from wearable devices, healthcare apps, and electronic health records to predict anxiety triggers and offer targeted support. We will also discuss the business and investment opportunities in this growing space, ethical considerations, and how to design inclusive technologies that empower individuals while fostering greater independence. This is not just about technology, it's about empowering people and making mental health care more accessible, personalized, and effective. So I'll start with understanding neurodiversity and impact on mental health. Neurodiversity refers to natural differences in brain function, including autism spectrum disorder, ASD, ADHD, dyslexia, and more. These individuals often experience unique cognitive profiles, different ways of processing information and emotions. Increased vulnerability to anxiety means unexpected changes, sensory stimuli, and social interactions can trigger anxiety. Another one is social and emotional challenges. This is difficulty in expressing emotions can make traditional therapy less effective. If we would like to consider an example, imagine 7-year-old child with ASD in a crowded shopping mall. The bright lights, overlapping conversations, and sudden noise can lead to sensory overload, triggering anxiety or a meltdown. That's where it is very important to understand neurodiversity and their trigger for anxiety. Next, we will talk about challenges. The challenges of traditional mental health approaches. Traditional mental health treatments often fail neurodivergent individuals because they are not designed for their needs. Lack of personalization. Most therapy follows a generalized model, but neurodivergent individuals require tailored interventions. So the challenges for lack of personalization are just the personalization for individuals. Another one is communication barrier. Verbal therapy assumes patients can clearly express their emotions, which isn't always the case. And the last one is sensory overload. Clinical environments like therapist office can be overwhelming due to noise, lighting, and unfamiliar settings. Let's take an example. A nonverbal autistic teenager may struggle with traditional talk therapy but could communicate through AI driven emotion recognition tools that analyze facial expressions and physiological responses. So here, challenges are that autistic teenager is nonverbal, so it is very difficult to communicate. So that's a barrier, and there are not many applications or tools which can personalize for that specific child. Now let's talk about AI in mental health care. How AI is transforming mental health. AI is challenging mental health care by shifting from reactive to proactive solutions. I will take a couple of examples here, like early anxiety detection, or personalized coping strategies, cognitive modeling, exposure therapy. When it comes to early anxiety detection, AI models analyze behavioral and physiological data to predict anxiety episodes. For personalized coping strategy, AI learns from the past patterns and tailors intervention for individuals. For cognitive continuous monitoring, AI powered wearables and smart assistants track mental health indicators in real time. The most important factor part of AI application when it comes to healthcare is data privacy and ethical consideration in AI mental health interventions. Using AI mental health requires strong ethical consideration to protect users. Key ethical concerns are data security. It's a sensitive mental health data must be encrypted and stored securely. Another one is informed consent. Patients should understand how their data is being used. Another one is bias mitigation. AI models must be trained on diverse data sets to avoid discrimination. And the last one is transparency. Users, patients should be able to trust AI driven recommendations. So we should be, all AI models or companies should transparent enough to provide what is happening with AI models, how are we sharing the data, and what are the outcome, what are the limitations. Those are very important. Next, I will consider a small case study. I will not deep dive into all the details, but I will explain the business use case and the case study for AI-driven wearable devices for anxiety prediction. That is my personal project that I have been working on. One of the most effective AI applications in mental health is wearable technology. We all wear Apple Watches, Aura rings, which tracks our data, gets our health data, and gives us some insights. How AI wearable work? Step one, it collects the data. Sensors track heart rate, sleep, and background noise. Step two, AI analysis. Once we get this data, then deep learning models detect anxiety triggers. Next step is personalized interventions. So AI suggests breathing exercises, music therapy, and alert caregivers. This is just the highlight of my case study. Now we can deep dive into each of the steps here. From noise detection to caregiver notification. We talked about the overview of how AI wearable work. Now we will talk about a very specific use case. AI can help neurodivergent individuals by detecting and managing environmental triggers. Um, Real-time noise classification, predictive anxiety analysis, and automated alerts and interventions. So AI is categorizing noise, then pattern working on or analyzing patterns and providing notification to caregivers. So these are some of the examples. So now we can look at some of the steps like data collection, noise categorization, AI classification, and alert system. Let's deep dive into data collection. The integration of wearable devices, background noise profiling, and EEG offer a comprehensive approach to understanding how environmental factors influence psychological and neurological responses. This data collection process is essential for AI driven mental health care solutions, particularly for neurodivergent individuals. AI model requires multimodal data from various sources. Couple of sources I have mentioned here. Wearable sensors collect physiological signals such as heart rate, HRV, electrodermal activity (EDA), respiration rate, and skin temperature. Another type is EEG data captures brain activity, detecting stress induced shifts in alpha, beta, and theta waves. Another one is noise and environmental sensors, measure real time background noises, lightning, lighting, and temperature to correlate environmental sensors with physiological responses. Another one is behavioral data. It monitors facial expressions, voice tone, and movement patterns through cameras or microphones to detect anxiety related behaviors. Moving on to next step, correlating noise, physiological data, and brain activity in AI-driven data integration. This is a very important and crucial part of this case study. Combining these data sets through AI models enables personalized noise sensitivity profiles, which is like mapping individual responses to different noise types. Another one is predictive stress detection, identifying early signs of cognitive overload before symptom escalates. Adaptive interventions, recommending real time solutions such as noise cancellation, guided breathing exercises, or environment adjustments. This all these steps or all these solutions are result of correlating noise and physiological data or brain activity. Once we correlate that, train our model, understand um, what is the correlation, then then this AI model can suggest appropriate response or solution. Step three, um, which is like AI driven discomfort level classification and anxiety prediction. We talked about data collection, we talked about correlating different factors. Now we can talk about classification. AI models classify discomfort levels by mapping real time data to prevent predefined anxiety categories. How we do that? By using supervised learning classification models. There are different machine learning models here: random forest, deep learning, CNN, LSTM, unsupervised learning, clustering models, K-means. These models identify hidden patterns in anxiety responses without predefined levels and useful for personalized profiling. Next one, once we work on machine learning models, develop our model, we can train our model with the real-time data or the data sets that we have. After that, another next step or important part is calculating anxiety scoring. So anxiety scoring system is to provide quantifiable metric. An AI driven anxiety score is computed based on real time input. Weighted scoring system, which combines multiple features, HRV, EDA, we talked about those, EEG, noise levels, to calculate an anxiety probability score, which is now like 0 to 100. Adaptive threshold, this is also part of anxiety scoring, adjust scoring dynamically based on individual baseline data. Another one is personalized anxiety index. Trained AI models can predict future anxiety levels based on historical patterns, enabling proactive interventions. And then the last one is real time training and continuous model updates. Edge AI and on device learning. Wearable AI models update in real time, refining predictions based on new data. Another one is like federal learning. Federal learning protects privacy while enabling continuous improvement across multiple users' data. Another one of this real-time adoption is reinforcement learning. AI adopts recommendations based on feedback from user behavior. For example, suggesting noise reaction if discomfort is detected. So these factors are very important when we incorporate these models into wearable devices. So next one is caregiver notification and early intervention. I would consider this as like the last step of our AI application. So how does AI assist caregivers in real time? Once AI detects an anxiety-inducing noise, it triggers personalized interventions to prevent an anxiety episode. So AI technologies used here are edge AI and information of technology integration. AI processes data locally on wearable for instant response rather than relying on cloud servers. Natural language processing for context awareness. AI understands verbal responses and emotional tone for caregivers to adjust its prediction. AI powered smart environments. AI integrates with home automation system to modify environment factors in response to anxiety signals. For example, Google's project Euphonium uses speech recognition AI to improve communication for nonverbal autistic individuals, enabling AI-driven responses based on voice pattern and distress signals. So there are like a couple of options we have. We talked about like predictive alerts, personalized recommendations that we just talked about, and an integration with smart home devices, the Google. There are like a use case here is smart home system linked to an AI-powered wearable detects a child stress reaction to a high-pitched car alarm outside. AI immediately alerts the patient via smartphone app. Smart home assistant lowers ambient noise, dims lights, and plays calming music. Another one is like if distress escalates, AI suggests guided breathing exercise via connected voice assistant like Alexa. So not only wearable devices helps patients through wearable devices, but also we can also connect that to home devices and help our patients in different situations, in diverse situations. Now, I will talk about some like real world impact on neurodivergent communities. Obviously, it is main goal is to reduce anxiety, uh, and we are trying to do that with notifying caregivers. Another one is improve social skills. We want our neurodivergent community to be part of social setup so that they can improve their personalities, improve their communication skills. They can be part of our group as well. And then another one is increased independence. We want our neurodivergent community to be independent with the help of AI solutions, so that they can have like empowerment through self management tools. Now, I will move on to a future of AI and neurodiversity. What are the opportunities and challenges here? How can AI further improve noise triggered anxiety management through personalized noise filters? Here I'm talking about personalized solutions. It could be anything, but I will take only a couple of examples here. For example, noise filters. AI customizes active noise canceling headphones based on individual stress trigger rather than canceling all the noise or loud music that we have in the background. Another one is real time speech emotion recognition. AI detects frustration and distress in voice tone and adjust responses accordingly. Another one is AI powered cognitive assistant. AI driven virtual assistant can interact conversationally with neurodivergent individuals to guide them through stress reduction exercises, to reduce anxiety episodes by predicting distress before it escalates, enhance caregiver response time through automated alerts, improve quality of life by creating personalized AI powered environments that adopt an individual needs. All this is part of personalized medicine, collaboration, innovation. For ethical frameworks, we can work on data privacy, biasness, and it is very important to consider all diverse data set. Um, with that, I would like to conclude today's presentation with a few pointers here. Our AI-driven noise detection and caregiver notification system present a major advancement in neurodivergent mental health support. By integrating real-time sound analysis, physiological tracking, and automated interventions, AI can do few things here. This technology is not just about monitoring, it's about creating proactive AI-driven support system that empower neurodivergent individuals to live with greater ease and independence. This expanded expansion incorporates AI models, real-world applications, and future scalability for high-impact discussion on noise trigger anxiety management. With that conclusion, I would like to say thank you for joining me today, and let me know how if you would like any let me know if you have any suggestions. I'm happy to answer those. Thank you so much.